Hi, so in the first video, I worked out the tree diagram of the binomial distribution where you would have a sample size of 3, where the probability is 0.25 of being defective. So here it is again, the tree diagram typed up. It looks a little neater. You can see when you follow along the branches how you multiply the probabilities. And of course, using a calculator, you can get those probabilities worked out. Now, our probability model here shows what would happen, what would the probability be of selecting 0 defective. In other words, if 0.25 is defective, that means 0.75 is not defective. And there's only one way that happens. So you can see that when you follow the branch here below, 0.75 times 0.75 times 0.75, which is 0.42188. There's only one way that could happen from this tree diagram. And if you look to the next one where it says, what's the probability of selecting 1 defective? So looking along here, I'm looking for 0.25 times 0.75 squared. And looking along that, there's one here, there's another one here, and there's a third one here. So they are actually highlighted here in green. What we would do is say 3 times that, or multiply it all out to get that probability. So that happens in 3 ways. That means there's 3 combinations where you can select that those chips. All right, and over here we have the 2 being defective. In other words, what's the probability of selecting 2 defective? Remember, the probability of defective is 0.25. So I'm looking for 0.25 squared. And looking at my tree diagram, I can see that this one is 0.25 squared. There's one here. There's another one here. And there is a third one here. So there's 3 ways that that could happen, which is why I have the coefficient 3 here. So if you remember Pascal's triangle that I mentioned before, that would be in the 3rd row, and your coefficients would be 1, 3, 3, 1. And the last way is to select 3 defective, and there's only one way of that occurring, and that is following the diagram here. So 0.25 defective, defective, and defective, multiply that out, and we would get 0.015625. Now, adding up all these probability, you should get that the total outcome equals 1. Now to answer the question. So letter A says, what is the probability of having 2 or more defective chips? So the probability of 2 or more is the same as the probability of having 2 plus the probability of having 3. So you can just add up the probabilities of 2 or more, which means you would add up 0.14064 and 0.015625. Now let me show you how to do this on your calculator, because as you can see, this is a lot of work, and this is actually using the binomial theorem formula. So looking at our calculator, because we want to know what is the probability of 2 or more being defective, I'm going to go ahead to my binomial distribution. So you can either reach that going to statistics or probability. So if you go to probability, you will go to distribution. So from probability, I will go to distributions right here. And from distribution, I'm going to scroll down to, or you can go to statistics, distributions, number 5, and then binomial CDF right here. All right, once you are at binomial CDF, then it prompts you to enter the number of trials. So we know that we have a sample size of 3, that is our N. The probability of success, in this case, we want to know of defective, so we would enter 0.25. Now, 2 or more means our lower bound is 2, and our upper bound would be 3. Now the number of trials, you can never have your upper bound greater than the number of trials. So once you click OK, there's our answer here, and we have our binomial CDF laid out this way. Now going to the next example, it's asking you what is the probability of having 1 or less. So looking at our probability model, we can just add up the probabilities for 1, which is 0.42188, and 0, which is 0.42188. You can add those two probabilities together, or using your calculator, you can go to, again, binomial CDF, enter your sample size 3, your probability 0.25. Be careful here, you enter your lower bound, which is 0, and your upper bound is 1. You should get the exact same answer. Now for the last one, where it asks you to find what is the probability of having exactly 2 chips. Well, this is different. If you're using your calculator, the CDF represents cumulative and PDF is exactly at that point. So going to our calculator, we're going to go to Menu and Statistics and Distributions. I'm going to click on Binomial, not CDF. Let me go back. I'm going to go to Menu, Statistics, Distributions, Binomial PDF. You can see that for here it is exactly at 1 point. We have 3 trials, that's our N. Probability of success, in other words, in this case we want to know how many defective, and exactly 2. So picking exactly 2 will get us to the probability. So it is 0.140625, which is actually rounded up to 3. So I would change this value right here to, let me rewrite that as 3.